Today's problem, minimum times A has to be repeated such that B is a substring of it. Okay, so we are given two strings A and B. Find minimum number of times A has to be repeated such that B is a substring of it. If B can never be a substring, then we return -1. Okay, so we are given two string A, B, C, D, C, D, A, B, C, D, A, B, and we need to find how many times like this has to be repeated. Like we have already one A, B, C, D. Now again there is no, like, this is not a substring. So in order to have a substring, like in order to have B as a substring in A, the length of A has to be, one of the conditions that we need to observe is the length of this A has to be greater than that of B. Okay, so that's one of the conditions. So up to that, like, we need to add until our length of A becomes greater than the length of B. We need to keep on appending this A, B, C, D, A, B, C, D, A, B, C, D, like that. So at a particular point, like, the length will become greater than B. So at that time, like, we will be just checking whether we are able to find CDAB, CDAB as a substring inside the newly formed A. If we are not able to find still, we just suppose, like, sometimes, like, we will be able to find it, like one more appending, after one more appending. So at that time, like, we just once more append A, and we again just check whether we are able to find B inside A as a substring. And if we find, like, it will be till the result +1. Otherwise, like, even though after adding one more A, we are not able to find B as a substring inside A, so we will return -1. So what I'm going to do is we are given ABCD. ABCD, this is our A, and what is our B? Our B is CD ABCD, CD AB CD AB. Okay, AB. So let's have the length. L1 denotes the length of A, it's 4 initially. Okay, and L2 is the length of B, and it is 1 2 3 4 5 6 7 8. Okay, it's 8. So at first, the length of A, 4, is less than 8. So what we do means, we are having ABCD. Okay, we append once more ABCD, A, B, C, D. So at first, like, we are already having A, so our result will be 1. Okay, next until our length become equal or greater than the length of B, we keep on adding A. So at first it's only 4, but the length of B is 8, so it's less, so we add one more ABCD. So now our length become 8. Okay, our newly updated length become 8, and since we added one more ABCD, our current result is 2. Okay, now the lengths are equal, it's not lesser. So now we can just check whether CDAB is present as a substring inside this. So the lengths are equal. So we can just, like, in Java, if we are doing in Java, there is index of operator, or sorry, not operator, index of method, well, which gives a positive result when we are able to find a particular index of a string or character, anything. Here we will be doing like A dot, inside A we are going to find the index of B. Okay, so in this, like, we will not find CDAB CDAB in ABCD ABCD. Like, we need to have the substring, not subsequence, we need to have the substring, so it will be continuous. So here we are not able to find ABCD. So now we just once more add A, we once more append. So A, B, C, D, this was the initial string, then since the lengths were not equal, we once more added, okay, but still we were not able to find b as a substring inside this. So in hope of finding it again, we just again do a, b, c, d. So now let's see this one, c, d, a, b, c, d, b, c, d. Now we have that substring that we are looking for. This is b. This is actually b, and our result increases by 3. Our length increases by 12. So this index will be actually giving us 0, 1, 2. Actually 2, and this 2 is greater than or equal to 0. So our result will be this one. That's the updated result 3. If we are not able to find, then our result will be -1. Let's check for the other ones more. So AB, CAB. So our A is AB and our B is, say, CAB. So already there is one AB appended. So our result is considered as 1. The lengths are L1 is 2 and the L2, which is the length of B, is 3. So the length of A is less than length of B. So what we do, we were having a AB, we again added AB. Fine. Now are we able to find CAB inside this string? There is one thing that we need to note, that there is no C at all inside this. So in ABAB, we are not able to find B as a substring. So once more, like in hope, it's a hope. Sometime if we again append A once more after becoming the length greater than or equal to B, okay, once more we are just adding it AB, because in the previous input, like we saw, like once more if we add, we were able to find that. But this time no, the one no, like we are not able to find CAB, so this time we'll be returning -1. So that's the algorithm. So the main thing that we need to have is index of, okay, index of. And so if we are doing s1 dot index of s2, here we are just checking whether in s1 we were able to find that part which contains s2, an index that is containing s2. So here it will be of order of big of s1 into s2. So the time complexity here will be big of s1 into s2. So the total time complexity for this problem will be big of s1 into s2. And let's see. So initially, like we are already having 1a. So let's have our result is equal to 1. Now I'm making use of a string builder SB, because string builder is like mutable and new objects will not be created upon appending. So it is always better to make use of string builder, and we are putting all the A. Okay. Now while SB dot length is less than B dot length. Okay. If SB dot length is less than B dot length, we append one more A and we increase our result. Okay. So at this case 4 was less than 8, so we once more appended A, so it becomes ABCD, and our result becomes 2. Like we appended ABCD 2 times, like there is already one ABCD, and then on top of that we added another one, which makes the result incremented. So we have now result 2. Now we will be checking if SB dot index of B is greater than or equal to 0. If we are able to find that, then just return whatever the result we are having. In this case, ABCD, CDAB, CDAB. But we will not be able to find CDAB inside ABCD. Okay. So in hope of finding, whether B will be present as a substring in A, upon appending one more A. So SB dot append of A, we are appending one more A, and once more checking, like our last hope, say it's our last hope, we are again checking whether we are able to find b inside that. If we are able to find, then our index will be greater than or equal to 0, then result plus 1. Then also, like, we are not able to find it, then return minus 1. So here we can say it's up to b dot length. Okay, so we are appending to this a, and as I told, the sb dot index of b, the time complexity is big of a into b. Okay, so the time complexity, the total time complexity will be big of length of a into length of b, or length of s1 into length of s2, whatever. And we are making use of a string builder. It's an extra space, and it will be of some length, like the a can be equal to b or greater than b. So we can say some kind of extra space, let's say big of space of the final, the length of the final a. We can say like that, that much big the new string builder will grow. So the time complexity will be big of s1 into s2. Space complexity will be big of the final length of a. So let's compile. Let's see what it's given. It's big of b. Okay, actually it can grow bigger, so we can say like that. Okay, it's, yeah, problem solved successfully. So this is, so the important thing is index of, or we can also make use of any pattern searching algorithm, like there is KMP algorithm for the pattern searching, but index of will do. In case of that, like, we will be able to find the result in big of a. So we might be able to reduce the time complexity, but for this case, like, since the constraint is only 100, this big of s1 into s2 will also pass. So yeah.